Space is not silent emptiness. It is not the peaceful black canvas we sometimes imagine when we look up at the stars. It is a graveyard, a battlefield, a cosmic theater of horrors where the laws of physics bend into shapes our minds can barely comprehend. The universe contains places so dangerous, so alien, that to even imagine standing near them feels like staring into the mouth of madness itself. These are not distant fairy tales. They are real locations, mapped by telescopes and predicted by the mathematics of astrophysics. And in tonight's journey, we descend into them, the scariest places in the known universe. Imagine floating at the edge of nothingness, your view filled not by light, but by the absence of it. Ahead lies a black sphere, perfect and absolute, blotting out the stars behind it. At first, it looks like a hole cut into the cosmos, but it is no hole. It is a black hole, an object so dense that even light cannot escape. If you drift too close, no rocket can save you. No scream can escape you. The laws of reality itself are rewritten at the event horizon. Einstein described them. Hawking wrestled with their paradoxes. And yet, the truth is, no one alive has the faintest idea what waits inside. A singularity, infinite density, zero volume, where physics breaks and the universe keeps its deepest secrets. To fall into one is to vanish, not just in body, but in history. Even the information that made you what you are may be erased from existence. But black holes are only the beginning. The cosmos hides places far stranger. Consider neutron stars, born from the fiery death throes of massive suns. These are corpses of stars that collapsed so violently their atoms were crushed into a single sea of neutrons. Imagine the mass of the sun squeezed into a sphere no bigger than a city. 1 teaspoon of neutron star matter weighs as much as Mount Everest. Its gravity is so strong that if you stood on the surface, you'll be flattened into atomic paste instantly. Some neutron stars spin hundreds of times per second, firing beams of radiation like cosmic lighthouses. If Earth wandered into their crosshairs, our atmosphere would be shredded in an instant. Others, magnetars, possess magnetic fields trillions of times stronger than anything humans can generate. These fields are so intense they could rip the electrons from your very atoms. Stand within 1,000 kilometers, and your body disassembles at the subatomic level. Still, even these terrors pale before what lurks in intergalactic space. Between galaxies lie vast voids, deserts of darkness stretching millions of light years across, almost completely empty. Drift into one, and you will be farther from any source of light or warmth than anywhere else imaginable. There, you will see nothing. No stars, no galaxies, only the crushing awareness of being utterly, completely alone. If you shine a flashlight, the beam would travel for millions of years before touching anything solid. These voids are so large, they make galaxies look like dust motes, yet they are stitched into the very fabric of cosmic structure. To enter one is to be erased from the story of the stars, condemned to wander eternity without even the comfort of a night sky. But not all horrors come from emptiness. Some come from chaos. Picture the heart of a globular cluster, where hundreds of thousands of stars are packed into a sphere only a few dozen light years wide. In these stellar hives, suns dance dangerously close, tugging each other with gravity, flinging planets into interstellar exile. No stable solar system can survive in such crowded neighborhoods. Any world born there will be doomed, its orbit destabilized, its oceans torn by tidal forces, its skies filled not with gentle constellations, but blinding suns only light days apart. Imagine standing on a planet where night never falls, where your sky is ablaze with 100,000 burning eyes, each one close enough to scorch your world into ash. Life could scarcely endure such proximity to chaos. Then there are gamma ray bursts, the most powerful explosions in the universe. When certain massive stars die, they collapse into black holes and unleash twin jets of energy so bright they outshine entire galaxies. A single burst can release more energy in seconds than our sun will emit in 10 billion years. If one occurred within our region of the Milky Way, Earth's atmosphere would be stripped away in moments, the oceans boiled, and the surface sterilized. No underground bunker, no shield of steel, could protect us. These cosmic snipers fire without warning, and while astronomers can see them across billions of light years, there is nothing we could do if one aimed in our direction. Still, the scariest places are not always the most violent. Some terrify because they bend the rules of existence itself. Consider the edge of the observable universe. Beyond it lies something, or perhaps nothing. We cannot know. The universe is expanding faster than light can cross it, meaning vast regions are forever beyond our reach. Any galaxies there will drift away until their light can never touch us. They may as well not exist, but they do. Somewhere out there, civilizations may rise and fall, stars may be born and die, entire histories written in light that will never reach Earth. To stand at the edge of the observable universe is to confront the ultimate isolation, knowing that most of reality is forever sealed away, inaccessible, unknowable. Yet even that is not the ultimate terror, for physics itself suggests places stranger than imagination. Wormholes, bridges through space-time, shortcuts across the cosmos. The equations allow them. Some theories suggest they form naturally inside black holes. Others that civilizations unimaginably advanced may construct them. But every wormhole comes with a catch: instability. Step into one, and it may collapse in the blink of an eye, crushing you into nothing or spitting you into another universe entirely. A place where the laws of physics are not our laws, where even the concept of matter may not exist. All of these places, black holes, neutron stars, voids, clusters, bursts, horizons, wormholes, exist in the cosmos we can see and measure. They are not stories invented to frighten children. They are written into the mathematics of relativity, into the data of telescopes, into the fossils of light that reach us across billions of years. And yet, the scariest places of all may be those we haven't found yet. Because if the known universe contains terrors like these, what horrors wait in the unknown? Prepare yourself. Our journey into the scariest places in the universe has only just begun. Picture a planet torn from the warm cradle of its star. Cast adrift, it drifts endlessly through interstellar night. Its oceans frozen solid, its skies empty, its landscapes buried beneath eternal ice. These are rogue planets, worlds without a sun, wandering the void between stars. Astronomers believe there may be billions of them in our galaxy alone, outnumbering the stars themselves. Some may be shattered remnants of ancient systems, flung away during gravitational chaos. Others may have formed in darkness from the start, never knowing the comfort of a parent star. Imagine standing on such a world. No sunrise, no sunset, only blackness broken by the faint glimmer of distant galaxies. The cold would be absolute, the silence unending. Yet deep underground, tidal heating or radioactive decay might still keep reservoirs of liquid water. And if life ever found a way to survive there, it would exist in darkness so total, so alien, that we might never recognize it as alive at all. A rogue planet is a place where hope dies, a cosmic orphan cut loose to wander eternity in exile. But not all exiles drift slowly. Some are hurled into the void like bullets. Hypervelocity stars race through the galaxy at speeds so great they can escape its gravity entirely. These stellar cannonballs are born when binary systems pass too close to the supermassive black hole at the galaxy's core. One star is consumed, the other is flung away at thousands of kilometers per second, faster than any planet, faster than any spacecraft humanity has ever imagined. Entire solar systems can be carried with them, planets, moons, and all doomed to speed forever into intergalactic emptiness. To stand on a world bound to such a star would be to watch your night sky shift in ways unthinkable. Constellations would unravel in mere lifetimes. Stars fleeing past as your system hurtled away from everything familiar. Eventually, your galaxy would shrink to a dim smudge on the horizon, then vanish entirely, leaving only the terrifying loneliness of intergalactic space. These are the cosmic runaways, the outcasts, flung across the universe at impossible speeds, never to return. And then there are places where motion itself becomes a weapon, galaxies colliding. Across the universe, these titanic encounters happen again and again, slow dances of unimaginable violence. Our own Milky Way is destined to collide with Andromeda in about 4 billion years. When it happens, the two spirals will stretch and twist into grotesque shapes, stars flung into long tidal tails that sweep across intergalactic space. Whole planetary systems will be ripped from their homes, thrown into the void, or trapped in new orbits around unfamiliar stars. Though stars themselves are small enough to rarely collide, the clouds of gas and dust between them crash together, igniting firestorms of starbirth that blaze brighter than the combined galaxies. If you lived on a world caught in this apocalypse, your sky would transform into chaos. Nights would be filled with a swirling storm of 1 trillion stars, nebulae glowing red and blue, novas erupting by the thousands. It would be a view both terrifying and magnificent, the heavens tearing themselves apart in slow motion. Survival in such a place would be nearly impossible. Radiation storms from newborn stars, gravitational disturbances, and ejected asteroids would scour planets of their atmospheres and oceans. Galaxies colliding are among the most beautiful horrors in the universe. Cosmic cataclysms that destroy and create on scales far beyond our comprehension. Some horrors are less obvious, hiding in plain sight. Imagine a planet orbiting so close to its star that its surface is a sea of boiling metal. Lava planets like 55 Cancri E exist worlds where entire hemispheres glow red hot, their rocky crusts vaporizing into toxic atmospheres of carbon monoxide and silicates. Winds on such planets carry clouds of vaporized rock that condense into rains of molten glass or metal. To step there would be to enter a nightmare of heat and fury, where landscapes shift and evaporate with every sunrise. Others orbit pulsars, neutron stars, blasting radiation like machine guns. A planet bound to one of these stellar corpses would be bombarded with lethal beams, its atmosphere stripped away, its surface sterilized again and again. Yet astronomers have found such worlds. They exist, and we can only imagine what remains on their surfaces: craters filled with ash, frozen oceans cracked beneath endless radiation storms. These are planets in hell, worlds that defy the very idea of habitability. But the scariest places are not always visible. Some lurk in silence, hidden by shadows. Supermassive black holes sit at the heart of nearly every galaxy. Invisible engines millions or billions of times the mass of the sun. The Milky Way's own central monster, Sagittarius A, is relatively quiet now, but evidence shows that in the past it flared with deadly power. In distant galaxies, we see quasar-supermassive black holes feeding so ferociously that their accretion disks blaze brighter than all the stars around them. They pour radiation into space with such intensity they can sterilize entire galaxies. The jets they fire stretch for millions of light years, spearing through intergalactic darkness like cosmic weapons. To be anywhere near one is to stand inside the exhaust of a god, bathed in energy no planet could endure. These galactic horrors are not merely destructive, they are unpredictable, their outbursts sudden, their reach cosmic. The knowledge that every galaxy harbors such a beast at its center should remind us that our universe is not safe, but precariously balanced on the edge of forces we cannot control. And yet, in every one of these horrors, there is a strange beauty. Rogue planets drifting in darkness, stars hurled like arrows across eternity, galaxies tearing themselves apart in luminous violence. Each is terrifying, but each also reminds us that the universe is vast beyond measure, indifferent to our fears, and filled with places stranger than any nightmare. The deeper we travel into this cosmic catalog of terrors, the more we realize the scariest places are not only those that threaten life, but those that challenge our understanding of existence itself. The universe is not merely dangerous. It is alien, filled with realities that stretch the limits of human imagination. And in the next step of our journey, we will descend even further into places so extreme that the very concepts of time, matter, and reality break apart.
Time itself is not constant. We live as though every second ticks by with the same steady rhythm, but in the deeper regions of the universe, time can twist and warp until it loses meaning altogether. Near the surface of a black hole, Time slows relative to the outside world. For you, moments pass normally, but to a distant observer, your clock ticks slower and slower, until it nearly stops. Imagine hovering near the edge of such a monster. You could spend what feels like a single day watching the stars, only to return and find millions of years have passed elsewhere. Civilizations would have risen and fallen in the time you lingered near the abyss. To visit such a place is to abandon any hope of synchronizing your life with the rest of the universe. The closer you move to the event horizon, the more reality itself stretches apart, until distance and time no longer mean what they should. It is a trap not of gravity alone, but of chronology, a prison where time itself betrays you. But black holes are not the only places where the fabric of reality becomes unstable. Dark matter, the invisible mass that makes up most of the universe, is everywhere, yet nowhere we can touch. We cannot see it, cannot hold it, cannot even prove its nature. We only know it exists, because galaxies spin in ways they should not, and clusters of galaxies bend light more strongly than visible matter can account for. Imagine wandering into a region where dark matter gathers in filaments, invisible rivers threading the cosmos. You would see nothing, yet its gravity would shape everything, bending light from distant galaxies, pulling matter into unseen currents. If dark matter is made of exotic particles beyond our comprehension, then entire structures could exist right beside us, ghostly scaffolds of invisible worlds, interwoven with our own. To realize that most of the universe is made of something we cannot experience directly is terrifying. It means our familiar cosmos of stars and planets is only the surface of a far stranger reality, one we do not yet understand. Beyond dark matter lies an even more unnerving presence: dark energy. While dark matter binds, dark energy tears apart. It is the mysterious force accelerating the expansion of the universe, driving galaxies farther and farther away from each other at increasing speed. Its existence means that the night sky of the far future will not be filled with countless galaxies, but with emptiness. Over trillions of years, galaxies beyond our local cluster will recede faster than light, vanishing from view forever. For any beings alive then, the universe will appear empty, its history erased, its true nature hidden behind a horizon of darkness. Dark energy suggests a terrifying end, a cosmos not collapsing in fire, but dissolving in isolation. If its strength increases, the expansion could accelerate until even atoms themselves are torn apart in what physicists call the Big Rip. Imagine watching your planet dissolve, the very fabric of your body stretched thinner than particles, reality unraveling into nothingness. Dark energy is not just frightening because it ends things. It is frightening because it operates everywhere, right now, shaping the fate of all that exists, and yet we have no idea what it actually is. But stranger still are regions where the ordinary structure of the cosmos appears broken. Astronomers have mapped massive cold spots in the cosmic microwave background, the faint afterglow of the Big Bang. One of these voids, hundreds of millions of light-years wide, seems to contain far less matter than expected. Some theories suggest it is simply a chance fluctuation, a natural emptiness. Others whisper something more disturbing, that it could be a scar from a collision between universes. If true, then our universe is not alone, but one bubble among many, each with its own laws of physics. A cosmic cold spot may be the faint echo of another universe brushing against ours, leaving behind an absence, a wound in the structure of space-time. To contemplate such a place is to confront a reality where the universe itself has borders, and those borders may not be safe. There are also places where energy and matter push themselves to the absolute limit, where exotic physics may govern existence. At the centers of some galaxy clusters, matter falls together with such intensity that shockwaves millions of light-years long ripple through intergalactic gaps. These shockwaves move faster than sound can travel in that medium, creating cosmic booms larger than entire galaxies. If you drifted into one, you would be swept by a wave of energy capable of heating entire star systems to millions of degrees. Your atoms would not merely burn, they would disperse into plasma indistinguishable from the firestorm around you. These are not places of stillness, but of eternal upheaval, where the scale of violence dwarfs human comprehension. And then there are cosmic strings, hypothetical relics from the birth of the universe. These infinitely thin, infinitely dense structures, if they exist, would slice through space like blades, warping space-time so violently that light itself bends around. A single cosmic string stretching across a galaxy could release more energy than all the stars combined. To encounter one would be to witness reality torn open, as though the universe itself were fraying at the edges. They may not exist, or perhaps they are out there, invisible, waiting for us to stumble across their path. The possibility that remnants of creation still wander the cosmos, capable of slicing planets apart without warning, adds a subtle layer of dread to the already hostile universe. Everywhere we look, we find places where the rules bend or break, where time slows, matter vanishes, energy accelerates, or existence itself begins to tear. These are not isolated curiosities, they are the natural fabric of the universe we inhabit, written into its very bone. The scariest thing about them is not just their violence or strangeness, but the realization that our safe little corner, the warm sun, the gentle blue sky, the comforting constellations, is temporary and fragile. The universe beyond does not care about safety. It is vast, alien, and filled with truths that can unravel the very concept of reality. And if these places seem terrifying, they are only the threshold. There are realms deeper still, where gravity bends space into labyrinths, where stars are consumed by forces older than galaxies, and where entire worlds are shredded before they ever have a chance to form. Our descent into the scariest places of the cosmos continues, into realms that turn terror into inevitability. In the depths of our galaxy lies a mysterious force that shapes the cosmos: black holes. These cosmic titans, born from collapsed stars, bend both space and time. Their gravitational pull is so intense that even light itself cannot escape their endless hunger. Imagine a star drifting too close to the mouth of a supermassive black hole. For billions of years it burned peacefully, but in one catastrophic moment, gravity seizes. The black hole's tidal forces tear it apart, stretching it like molten taffy. Astronomers call this a tidal disruption event. To an observer, the star appears to unravel in slow motion, its gas spiraling into a glowing disk hotter than anything found in a star's core. The black hole devours it piece by piece, releasing a flare of radiation so bright it outshines the entire galaxy for months. If Earth orbited near such an event, our world would be sterilized in an instant. The light alone could strip away our atmosphere. The debris raining outward could bombard planets with lethal energy. For the star it is annihilation, for the universe it is just another meal. Yet the most frightening aspect is not the destruction itself, but the inevitability. Galaxies are filled with stars orbiting ever closer to their central black holes. Sooner or later, every one of them will be consumed. Every orbit is a countdown, every system a meal waiting to be claimed. If our sun resided in the crowded core of the Milky Way, we would live under the constant shadow of this fate, never knowing when the beast at the heart of the galaxy might claim a new victim. Move closer to an accretion disk and terror takes on another form. These disks of gas and dust spiral into black holes at near light speeds, compressing into storms of unimaginable violence. Temperatures climb into the millions of degrees, magnetic fields twist into chaotic knots, and radiation pours out across the spectrum. Within these disks, matter is shredded, atoms stripped bare, protons smashed together in nuclear chaos. To be caught inside one would be to enter an environment more hostile than the surface of any star. Time dilates, space curves, energy rages in endless fury. It is not merely destructive, it is alien, a place where the normal states of matter cease to exist. But black holes do not need accretion disks to terrify. Some unleash jets, beams of plasma that erupt from their poles, blasting across millions of light years. These jets move at relativistic speeds, nearly as fast as light, and carry more energy than all the stars of a galaxy combined. Imagine a civilization unlucky enough to orbit within the path of such a jet. Their world would be bombarded with radiation for thousands of years, sterilized again and again, until nothing survived. Even planets far beyond the immediate blast zone could see their atmospheres stripped away. To stand within view of such a jet is to watch a weapon larger than galaxies being fired into the void. Not all destruction comes from the centers of galaxies. Sometimes entire galaxies themselves unleash storms. Galactic winds erupt when supermassive black holes feed too aggressively. The torrent of energy blasts outward, driving gas and dust from the galaxy itself. These winds are so strong they can shut down star formation across billions of solar systems, snuffing out the birth of new suns and dooming entire regions to eternal darkness. If our galaxy's core erupted in such fury, The Milky Way would gradually die. Future generations would see fewer stars, fewer worlds, until only cold remnants remained. Galactic winds are not explosions, they are slow suffocations, draining the potential of galaxies, until they wither into silence. Closer to home, horror takes the form of unstable stars. Hypergiants and Wolf-Rayet stars burn with such ferocity that they shed their outer layers in violent eruptions, sending shockwaves across space. Some swell and contract unpredictably, their brightness flickering like dying candle. If Earth orbited one, we would be bathed alternately in searing radiation and deep cold, an environment no life could endure. Worse still are the stars that end not with quiet fading, but with detonations that echo across galaxies. Supernovae release more energy in days than the sun will in its entire lifetime. If such an explosion occurred within 30 light-years, Earth's ozone layer would be obliterated. Radiation would cascade across the planet, triggering mass extinction. Astronomers suspect past supernovae may already have reset life's course on Earth, pruning evolution in ways we can only guess. Even stranger are the supernova imposters, eruptions that mimic the power of stellar death, but leave the star intact. These events can repeat again and again, as though the star itself is trapped in endless cycles of near-death, each outburst expelling vast amounts of matter. Nearby planets would endure apocalypse after apocalypse, surviving one storm only to be shattered by the next. Life there would never have a chance to evolve beyond the simplest forms. To exist in such a system would be to endure endless trauma, a world caught in an eternal catastrophe. Then there are binary star systems, where two giants orbit so close they exchange matter. Streams of plasma arc between them, like bridges of fire, feeding one star at the expense of the other. Sometimes the smaller star swells and explodes, sometimes the larger one collapses under the stolen weight. To live on a planet orbiting such a pair would be to witness constant chaos in the skies above, vast plumes of stellar gas twisting across the heavens, as though the stars themselves were tearing each other apart. At the most extreme, some of these binary systems collapse into pairs of neutron stars or black holes. When they spiral together, they release gravitational waves, ripples in space-time itself, that sweep across the universe. The final moments before their collision unleash bursts of gamma rays, so violent they can be detected billions of light-years away. If such a merger occurred within our region of the galaxy, the blast could erase us before we even saw it coming. Astronomers now detect these mergers with instruments that feel the trembling of space-time. Each detection is a reminder, somewhere out there, the universe is ripping itself apart. The scariest thing about these events is not that they are rare, it is that they are common. Stars are torn, planets flung, galaxies reshaped every moment, across distances so vast, we barely register them. The universe is not a calm sea with occasional storms. It is a storm without end, and we exist only in a temporary loss. And as terrifying as stellar death and galactic fury may be, they are still events we can observe, still governed by rules we can at least describe. Beyond them lie places that seem to defy even the laws of physics, places where light curves into impossible paths, where matter slips between realities, and where the very structure of space-time itself begins to fracture. Those are the realms we must enter next, where the scariest places in the universe transform from violence into impossibility. There are places in the universe that should not exist, regions predicted by mathematics but almost too strange to accept. If black holes represent nature's ultimate trap, then white holes are their impossible mirror. The equations of general relativity suggest they could exist, objects that nothing can enter, only exit. Imagine a fountain of matter and energy pouring endlessly into space, a wound in reality that vomits creation instead of swallowing it. No star could form such a thing. No natural process we know could sustain it. If one ever appeared, it would shatter our understanding of physics. To approach it would be futile. Every attempt to draw closer would push you away, space itself refusing your passage. Yet if they exist, they may be linked to black holes through hidden tunnels, their violence connected across distances we cannot see. The thought is terrifying. Perhaps every black hole in the cosmos is secretly paired with another universe, disgorging our dead stars into alien skies we will never know. And then there are naked singularities, the theoretical monsters stripped of even an event horizon. In a black hole, the singularity, the point of infinite density, is hidden behind the veil of the horizon, safely concealed from the rest of the cosmos, But if a naked singularity exists, it would lay bare the raw impossibility of physics itself. Time, space, causality, all would shatter in its presence. The laws of nature that govern our universe would collapse into chaos, and no equations could predict what might happen. Astronomers pray such things cannot exist, because if they do, they could rewrite reality in ways we cannot prepare for. To be near one would be to stand at the edge of lawless creation, where anything might erupt from the void, infinite gravity, infinite heat, infinite madness. Yet even more chilling is the possibility that destruction lurks, not in some exotic object, but in the very ground of reality itself. Quantum physics suggests our universe may not be perfectly stable. Instead, we might live in a false vacuum, a precarious state that could collapse without warning into a lower energy configuration. If such a vacuum decay occurred, it would create a bubble expanding at nearly the speed of light, rewriting the laws of physics inside it. Molecules would cease to bind, atoms would dissolve, even the fundamental constants would shift. There would be no warning, no escape. One moment you exist, the next you are erased by a wavefront of new reality. The terrifying truth is that this could already have happened billions of light years away, the bubble speeding toward us faster than any signal could warn. The end of everything could arrive at any instant, and we would never see it coming. Cosmic horror deepens when we consider that our universe may not be alone. The multiverse hypothesis suggests that countless other universes exist, each with different laws, different constants, different structure. Most would be lethal to life, as we know it, too much gravity crushing matter before it can form stars, or too little to allow galaxies to coalesce. Some might contain dimensions curled and twisted beyond comprehension. The boundary between universes may be violent. If two collided, the energy released would make every supernova, every black hole, every quasar look like a spark compared to a wildfire. The scars of such collisions might already be written in the sky, in cold spots, and strange patterns in the cosmic microwave background. If so, then we live in a universe marked by ancient impacts, with others, silent reminders that even reality itself is vulnerable to cosmic accidents. At smaller scales, the quantum world hides equally unnerving possibilities. Particles can appear and vanish in the vacuum, flickering in and out of existence. If these fluctuations can grow under the right conditions, they might spawn entire universes. Some theories suggests that black holes themselves may be seeds of new realities, each collapse birthing a cosmos hidden from ours. That means the universe may be not a singular entity, but a tree with endless branching worlds, each born in the death of a star. And if that is true, then somewhere, right now, universes are blooming out of nothingness, their own galaxies, their own histories, their own horrors unfolding unseen. There are stranger possibilities still whispered by the edges of physics. Wormholes, bridges through space-time, could connect distant points in our universe, or link to others, but stability would require exotic matter with negative energy density, something we have never observed. A stable wormhole could allow travel across the cosmos in an instant. But what if it collapsed while you were inside? What if it opened not to familiar stars, but to regions where time flows backward, or where space itself tears apart? Every wormhole would be a gamble, a doorway not only to elsewhere, but to annihilation. To step through would require faith, not just in physics, but in luck against infinite danger. And yet, even these theoretical nightmares are not the most unsettling thought. The scariest possibility is that the universe is not merely hostile, but does. Some physicists note that the constants of nature seem finely tuned for life. Gravity is weak enough to allow stars to burn for billions of years, yet strong enough to form galaxies. The charge of the electron, the strength of nuclear forces, the mass of particles alter them even slightly, and no complex matter could exist. To some, this suggests a multiverse, where countless combinations exist, and we happen to live in one that permits us. But another interpretation is darker, that the universe may be tuned intentionally or not, to create intelligence, only to expose it to endless cosmic terror. If the cosmos is not random, then the horrors we see may be part of its design. In contemplating these places, white holes, naked singularities, false vacuums, multiverse collisions, we are forced to admit something unsettling. The universe is not simply a stage on which we exist. It is unstable, unpredictable, perhaps even malicious in its indifference. Our safety is an illusion, a fragile arrangement that could collapse with a whisper from the quantum world, or a brush from another universe. And still, the descent goes deeper. Beyond the speculative physics and existential nightmares are places that we can actually observe, right now, where the environment itself is more hostile than any imagination could conjure. Worlds of diamond storms, planets of eternal fire, and regions where space itself rages, with radiation strong enough to erase matter in moments. Those are the realms waiting next, reminders that the universe does not need to invent impossible physics to terrify. It already has places where terror is woven into every particle. Some of the scariest places in the universe are not theoretical at all. They are real worlds, discovered by our telescopes, circling distant stars. When we think of planets, we imagine Earth-like havens, blue oceans, green forests, skies full of clouds. But most exoplanets are nothing like that. They are nightmares sculpted by physics, each one stranger and more hostile than the last. These are places that remind us how rare and fragile our home really is. Take HD 1T9733b, a gas giant locked so close to its star that temperatures soar to more than 1,000 degrees Celsius. Its winds roar at speeds of over 5,000 miles per hour, carrying particles of silicate dust. Imagine standing there if you could, glass raining sideways at supersonic speeds, shredding everything in its path. Nothing could endure that storm. The very air would be razors, the sky itself a weapon. To look upon such a world is to realize that nature does not care for comfort. It creates beauty that kills. Travel farther and you might encounter 55 Cancres, a planet so close to its star that its surface glows red hot. Days there are eternal fire, nights suffocating darkness. But beneath the crust, models suggest something almost unbelievable. The planet may be made largely of carbon, compressed by its immense gravity into diamond. Entire mountain ranges of glittering crystal may stretch across its tortured landscape, gleaming beneath a sky of fire. And yet this is no paradise. The heat would melt steel, the pressure would crush you instantly, and the wealth of diamonds would mean nothing in a place where life cannot exist. It is a jewel forged for no one, a treasure locked forever in a tomb of flame. Other planets are frozen in eternal imbalance. Tidally locked worlds face their stars with one side always burning and the other always frozen. On one hemisphere, oceans boil into clouds. On the other, atmosphere collapses into glaciers. Between them lies a twilight band where fire and ice meet, a narrow strip where winds rage as hot and cold air clash endlessly. If life ever tried to cling to such a place, it would have to survive in a knife-edge zone of storms and chaos, forever caught between extremes. The skies there would be filled with boiling cyclones, walls of vapor colliding with glaciers, taller than mountains. For any living thing, existence would be a battle against the very sky. Consider planets orbiting pulsars. These stars are dead, collapsed into neutron stars that spin and beam radiation into space, like cosmic lighthouses. A pulsar planet lives under constant bombardment of gamma rays and X-rays, its atmosphere stripped away again and again. Yet we have found them, rocky remnants, circling corpses of suns. What kind of world is that? The surface must be scarred with layers of fused rock, oceans long evaporated, landscapes bleached by endless radiation. If any life remains, it would be unrecognizable, creatures of stone and shadow, clinging to existence beneath the ruins of their sky. To even imagine such life is to stare into the darkest reaches of possibility. Then there are super-Earth, planets far larger than our own, with gravity so strong that every step would feel like carrying a mountain. The atmosphere of such worlds might be thick, crushing and toxic, oceans pressing down with unimaginable weight. Even if conditions allowed life, it would be shaped into forms we cannot imagine, built to withstand pressures that would obliterate us instantly. On such a world, flight would be impossible, motion sluggish, evolution sculpted by gravity's iron fist. The ground itself would be a prison, holding everything down with relentless force. To visit one would be to feel your body fail against a weight it was never meant to bear. Some exoplanets are born in chaos and never escape it. Kepler 36b and Kepler 36c orbit so close to each other that they pass within a few 100,000 miles, closer than Earth's moon. Every encounter must unleash unimaginable tides, earthquakes splitting their crusts, volcanoes erupting as gravity tugs mercilessly. To live there would be to endure an apocalypse every orbit, your sky filled with a neighboring planet so close it dominates the horizon. Each pass would be a reminder that the universe builds beauty not for us, but for itself, and beauty often comes with destruction. Even more terrifying are the hot Jupiters, gas giants that skim the surfaces of their stars, so close they are nearly touching. Their atmospheres boil and stream away into space, creating comet-like tails of gas tens of thousands of miles long. Imagine a sky where the very air escapes into the void, where the horizon glows as your planet bleeds itself into space. These worlds are doomed, their lifespans measured not in billions of years, but in millions, their bulk consumed by the very stars that gave them birth. And somewhere out there, there are planets we have not yet seen, worlds orbiting in places we do not expect. Imagine a world inside the event horizon of a black hole, where time stretches into infinity. Imagine a planet floating in the darkness of intergalactic space, forever frozen, cut off from all warmth. Imagine a planet orbiting two stars that erupt unpredictably, caught between dueling suns that never let it rest. The possibilities are endless, and almost all of them are terrifying. The scariest thing is not just that these worlds exist, it is that they are common. The galaxy may hold trillions of planets, and most of them are inhospitable, violent, merciless. Earth is the exception, a fragile oasis in an endless desert of fire and ice. To look at these places is to see how small and lucky we are, and how easily luck can end. But even these planets, with their storms of glass, oceans of fire, and skies of radiation, are only fragments of the cosmos's true horrors. Beyond them lie places where not even worlds survive, where galaxies themselves twist into grotesque forms, and where forces larger than imagination tear the universe into shapes no mind can hold. Those are the places we will turn to next, stepping beyond planets into the vastest terrors of all.
Galaxies are vast beyond comprehension, sprawling collections of hundreds of billions of stars, planets, black holes and clouds of gas bound together by gravity. To us, a galaxy is already an ocean too large to cross, yet galaxies themselves are only fragments of something far greater. They are woven into enormous clusters, colossal gatherings of hundreds or even thousands of galaxies, linked by strands of dark matter and blazing with X-rays from superheated gas. These clusters are among the largest structures in the universe, and also some of the most terrifying. Imagine drifting through the heart of a galaxy cluster. The space between the galaxies is not empty, but filled with a plasma so hot it glows in X-rays, heated to tens of millions of degrees. This intergalactic medium is invisible to our eyes, but deadly. Any solid object entering it would be stripped of its atmosphere and surface within moments, atoms torn apart by the relentless storm. Even stars, if flung into this environment, would slowly erode as their outer layers evaporated into the gas. To be here is to float in a furnace without walls, surrounded by galaxies shining like lanterns in an endless ocean of fire. The scale of violence inside a cluster is staggering. Galaxies collide regularly, smashing together in slow-motion catastrophes that last for billions of years. As they pass through one another, their gas is torn away, leaving behind ghostly trails that stretch across millions of light-years. The famous Bullet Cluster reveals this horror clearly. Two galaxy clusters collided, and their hot gas slammed together, while the invisible dark matter passed straight through, dragging the galaxies with it. The result is a vast cosmic wound, proof that much of the universe's mass is hidden in forms we cannot see. To witness such an event would be to watch entire galaxies stripped bare, their stars flung into intergalactic space, their futures rewritten by collision. Even more unsettling are gravitational lensing maelstroms that cluster cores create. The sheer concentration of matter warps spacetime so strongly that light bends around them, creating distorted images of galaxies far behind. To look into such a sky would be disorienting. Spirals stretched into arcs, galaxies duplicated across the heavens, space itself transformed into a kaleidoscope of impossible shapes. What you see is not reality, but a twisted version, a funhouse mirror built on gravity's endless power. For astronomers, lensing reveals the hidden scaffolding of the cosmos. But for a traveler inside such a place, the sight would be deeply disturbing, an environment where your very vision betrays you, where nothing you see is quite where it appears to be. Clusters themselves are not isolated. They connect to something larger still, the cosmic web. Across the observable universe, galaxies and clusters are strung together by vast filaments of dark matter, forming structures hundreds of millions of light-years long. Between these strands are supervoids, immense deserts, where almost nothing exists. The cosmic web is the true architecture of the universe, bright, thin threads glowing with galaxies,
surrounding bottomless voids of darkness. To drift across such a void would be to enter a silence beyond imagination. No stars, no galaxies, no light at all, just emptiness stretching for hundreds of millions of light years. Your sky would be a black canvas, punctured only faintly by the glow of distant filaments, at the edge of perception. It would feel like falling into infinity, surrounded by nothing but your own isolation. These voids are among the most frightening places we know, because they are real and unimaginably vast. The Bootes void, for example, is nearly 1 billion light-years across, containing only a handful of galaxies, where we would expect thousands. To enter it would be to remove yourself from the universe, cut off from the structures that give it shape. Time inside a void would feel wrong, not because it truly slows but because the absence of change would be absolute. With no nearby galaxies to evolve, no collisions to spark star formation, no bright clusters to light the skies, existence inside such a place would feel like waiting forever in a universe already dead. And yet, the cosmic web is not static. Filaments draw galaxies toward one another, feeding clusters, driving the growth of larger and larger structures. The largest of all is the shapely supercluster, a concentration of mass so immense, it pulls our entire region of the universe toward our galaxy, our local group, even our supercluster, the Laniakea, are all falling slowly toward this gravitational behemoth. We are being dragged across the universe, and there is nothing we can do to stop. Our sky may look serene, but we are in motion, on a one-way journey toward a cosmic abyss. Inside the densest knots of the web, galaxies merge into monstrous ellipticals, titanic spheres of stars that contain trillions of suns. At their cores lurk black holes so massive they dwarf imagination, devouring matter at such rates they can shut down star formation across entire clusters. These are not galaxies in the familiar sense, with spiral arms and nebulae. They are bloated giants, dead and red, filled with old stars and little else, the embers of once vibrant systems. To wander into one is to enter a cosmic mausoleum, where the light of youth has long since faded, leaving only the cold glow of ancient sun. The terrifying truth is that this structure, the web of filaments, the clusters, the voids, is not just the largest thing in the universe, it is the universe, and we are a part of it, a mote of dust, clinging to one faint strand. From the heart of a cluster furnace, to the silence of a supervoid, these places dwarf not only our bodies but our entire history. They remind us that scale itself is a kind of horror, one that can crush the imagination, as surely as gravity can crush a star. But even this architecture, immense as it is fragile, for the universe is expanding, and the filaments are stretching. In the far future, galaxies not bound to ours will recede beyond reach, torn away by dark energy, leaving only the faintest traces of this grand web. The scariest places are not only those that exist now, but those that will exist in the future. A universe of isolation, where the grand design unravels strand by strand until nothing remains but darkness. And if we dare look deeper, beyond the web, beyond the clusters and voids, we begin to confront the possibility that the universe itself may end not with silence, but with violence on scales beyond comprehension. That is where our journey must lead next, into the terrifying futures of all that exists, the apocalyptic destinies written into the very physics of the cosmos. The universe feels eternal. When we look into the night sky, we see stars scattered across blackness, galaxies stretching for billions of light-years, and it feels as though it will always be this way. But nothing lasts forever. The cosmos has a future, written not in myths but in physics, and that future is terrifying. To imagine it is to confront the end not only of stars and galaxies, but of time, of matter, of everything. The scariest places in the universe may not be where we stand today, but where the universe is destined to go. One possible ending is the heat death. The second law of thermodynamics tells us that entropy always increases, order decays, energy spreads out. Over unimaginable timescales, stars will burn out, galaxies will dim as star formation ceases, planets will grow cold, their suns reduced to ember. Eventually only the faint glow of white dwarfs, neutron stars and black holes will remain. As trillions of years pass, even those will fade. White dwarfs will cool into black dwarfs, dark, frozen, remnants. Neutron stars will radiate away their energy, growing cold and dead. The universe will become a graveyard of invisible cinders, drifting in an ever-expanding void. But even then, the story continues. Black holes themselves will evaporate through Hawking radiation, shrinking slowly over unimaginable lengths of time. A stellar mass black hole would take 10-7 years to vanish. A supermassive one at the center of a galaxy could take 10 centaurs, years, or more. When they finally evaporate, they will release their energy in faint, ghostly flashes, the last fireworks of a dying cosmos. After that, only particles will remain: protons, electrons, neutrinos, photons. Yet even those may not endure. Some theories suggest protons are unstable and will eventually decay. If so, then after about 10 to 4 years, all matter will disintegrate into radiation. The universe will be nothing but a thin soup of photons and ghostly particles, spread across a space too vast for them to interact. That is the heat death, not fire, but silence, an eternal darkness, where nothing ever happens again. Another ending is the Big Crunch. If the expansion of the universe is not eternal, but slows and reverses, then gravity will one day pull everything back together. Galaxies will halt their flight and begin to collapse inward. Over billions of years, the sky would grow brighter as galaxies crowd closer and closer. Radiation levels would rise as stars ignite in waves of furious formation, feeding on the chaos. Eventually, all matter would rush toward a single point, the universe collapsing into a firestorm hotter than the Big Bang itself. Everything: galaxies, stars, planets, even atoms, would be consumed in the final collapse. The Big Crunch is annihilation through pressure, the universe devouring itself until nothing remains but a singularity. Some speculate that such a collapse could trigger another Big Bang, a rebirth of everything. If that is true, then the universe is not linear, but cyclical, endlessly dying and being born again. But whether this is rebirth or eternal repetition, it is still death for everything we know. More terrifying still is the Big Rip. This scenario depends on the nature of dark energy. If its strength increases with time, then the accelerating expansion of the universe will grow faster and faster, until it overwhelms all forces. First, galaxies will be torn from each other. Then stars will be ripped from galaxies. Planets will lose their orbits. Eventually, gravity will no longer hold worlds together, and Earth itself will be shredded. As the rip nears its climax, even molecules will be torn apart, atoms stretched until their nuclei dissolve. In the final moments, space-time itself will be ripped open, torn into fragments. The Big Rip is the most violent of all endings, the dismemberment of the cosmos at every scale. It would not simply end life, it would end the very possibility of matter. There are stranger possibilities too. Perhaps the universe is trapped in a false vacuum, a temporary state of stability. If so, it could collapse into a true vacuum at any moment, rewriting the laws of physics everywhere. This vacuum decay would sweep through the universe at the speed of light, erasing everything without warning. Gravity, electromagnetism, the nuclear forces, all would shift. Atoms would dissolve, stars would vanish, life would be extinguished in an instant. What makes this scenario so horrifying is not only its totality, but its unpredictability. It could happen tomorrow. It could happen a trillion years from now. We would never know until it arrived, and then it would be too late. Each ending reveals something profound about existence. Heat death tells us that the universe is fragile, destined for silence. The Big Crunch reminds us that collapse is as natural as expansion. The Big Rip shows us that even the bonds of matter are not eternal. Vacuum decay whispers that reality itself is unstable, that we may live in a world balanced on a knife's edge. To contemplate these futures is to realize that permanence does not exist, that everything is temporary, no matter how vast. And yet within these terrifying visions lies a strange beauty. The heat death may erase all structure, but it means that the universe will persist, in some form, for longer than any mind can imagine. The Big Crunch may destroy us, but it may also ignite another creation, a cycle without end. The Big Rip may tear everything apart, but in its violence, it reveals the raw power of cosmic expansion. Even vacuum decay, in its horror, shows that reality is dynamic, restless, never fixed. We are alive now in a brief window where stars shine, galaxies thrive, and the universe is vibrant. That window will not last forever, but knowing the futures ahead does not make our present meaningless. It makes it more precious. The scariest places in the universe are not just out there in space, they are also ahead in time, waiting for us. But even these apocalyptic fates are distant, abstract, beyond the reach of any human lifetime. There are terrors much closer, far more immediate, cosmic events that could erase us, not in trillions of years, but tomorrow, without warning. Gamma ray bursts, supernovae, rogue stars, invisible threats, hurtling through the dark. These are the horrors we face in the present universe, dangers woven into the cosmos we call home.
Some dangers do not wait for the end of time. They are here, in our galaxy, unfolding across scales that can destroy civilizations in moments. We tend to think of Earth as safe, but space is restless, filled with silent killers that could erase us long before the universe's distant fates arrive. These threats are immediate, unpredictable, and terrifying, not only for their violence, but for their indifference. Consider gamma ray bursts. These are the most energetic explosions we know, releasing more energy in seconds than the sun will produce in its entire lifetime. They are thought to occur when massive stars collapse into black holes, or when neutron stars merge, unleashing jets of radiation that pierce across space like cosmic sniper fire. If one were aimed at Earth from within a few thousand light-years, our ozone layer would be stripped away instantly. Radiation would pour down, sterilizing the surface, igniting mass extinctions. Entire ecosystems would collapse in days. Gamma-ray bursts are not steady threats but sudden assassins. One moment, the sky is calm. The next, invisible beams have turned your planet into a grave. Astronomers suspect one may have struck Earth in the past, contributing to a prehistoric extinction. It may happen again. Closer still are magnetars, neutron stars with magnetic fields, trillions of times stronger than Earth's. When they release their energy in flares, the outbursts can momentarily outshine all other stars in the galaxy combined. A single flare, if nearby, could disrupt Earth's atmosphere and fry electronics worldwide. But the real danger lies in proximity. The magnetic field of a magnetar is so extreme that it can distort atoms, pulling electrons into elongated orbits. If Earth somehow wandered close enough, human biology would unravel, not through heat, not through radiation, but through the destruction of the very bonds that hold matter together. To stand on such a world would be impossible. Your body would not exist as a body. You would dissolve into atoms twisted by magnetic force. And then there are rogue planets, worlds without stars cast adrift in the darkness between systems. Astronomers believe there may be more of them than stars, wandering endlessly through interstellar night. They are invisible, frozen spheres of rock and ice, or gas giants, with deep dark atmosphere. If one entered our solar system, it could disrupt planetary orbits, sending Earth spiraling toward the sun, or flinging us into the cold void. These encounters are rare, but given the sheer number of rogue worlds, the threat is real. To imagine it is to picture the night sky shifting, stars wandering as Earth is pulled from its stable orbit into chaos. No warning would save us. A single passing giant could undo billions of years of stability. Asteroids and comets are a more familiar danger, but no less terrifying. We live in a solar system littered with debris, remnants of its violent birth. Most are harmless, orbiting quietly, but history shows us that collisions happen. 66 million years ago, an asteroid just 6 miles wide ended the reign of the dinosaurs, triggering firestorms, tsunamis, and a global winter. Today we know of many near-Earth objects, but countless more lurk unseen. A rock only a fraction of that size could devastate human civilization, collapsing agriculture, shattering economies, and killing billions. Larger ones could erase us entirely. It is not a question of if, but when. The Earth moves through a shooting gallery, and survival depends on luck and vigilance. There are subtler threats too. Our own sun, so familiar and life-giving, is capable of violent outbursts. Solar flares and coronal mass ejections hurl plasma and radiation into space, sometimes directly toward Earth. The strongest of these, like the Carrington event of 1859, can overload electrical grids, ignite fires, and disrupt satellites. If a storm of that magnitude struck today, it could collapse the global infrastructure that supports modern life, power, communication, water, food. Civilization itself could be crippled by a single tantrum from the star we depend on. And compared to other stars, the sun is calm. Around the galaxy, stars flare with a ferocity that would sterilize any nearby world. To live under such a sky would be impossible. Every day a roll of the dice between survival and annihilation. Even our own galaxy is a source of menace. The Milky Way is full of black holes, many of them wandering invisibly through space. A rogue black hole could pass close enough to disturb the Oort cloud, sending a rain of comets into the inner solar system. It might shift planetary orbits, or even capture worlds entirely. Unlike a star, it would give no light to betray its presence. Only its gravitational pull would reveal it, and by then it might be too late. To imagine the sudden tug of an unseen giant altering the entire course of Earth is to realize how fragile our stability really is. Cosmic radiation itself is a constant hazard. High-energy particles stream through space from supernovae, quasars, and other violent events. On Earth, our atmosphere and magnetic fields shield us from the worst of it. But astronauts outside that shield endure a constant bombardment, their DNA shredded by invisible bullets of energy. Over time, radiation makes life in deep space nearly impossible without heavy protection. And if Earth's shield were ever stripped away by a gamma-ray burst, a supernova, or even long-term decay of the magnetic field, the surface of our planet would become uninhabitable. The truth is that space is not safe, it is not calm, it is an environment of constant danger, and we survive only because of a thin atmosphere and the luck of our position. For every serene starry night, there are forces at work that could end us in moments. Gamma-ray bursts waiting in distant galaxies, magnetars spinning like cosmic bombs, rogue planets drifting silently in the dark, asteroids moving unseen on collision courses, the sun itself holding storms in its heart. We think of apocalypse as myth, as story, but in the universe, apocalypse is natural law, extinction is common, destruction is ordinary. The scariest places are not always distant. They can be as close as the rock tumbling unseen in our sky, or the star whose tantrum we have yet to witness. And yet, even as these threats loom, there are places worse still, regions so hostile that they challenge not just survival, but existence itself. Places where the laws of physics themselves turn cruel, where matter cannot persist, where light itself is twisted into oblivion. To continue our descent, we must turn to these absolute extremes, where terror is not just probable, but certain. ChatGPT said, there are places in the cosmos where danger is not just immense, but absolute. Not environments that merely threaten life, but domains where the very idea of survival becomes meaningless. These are the extremes of physics, worlds where matter itself struggles to exist, where energy and gravity conspire to create realms no living thing could endure. To imagine standing in such places is to imagine being unmade, your atoms scattered, your time fractured, your reality distorted, until nothing recognizable remains. Consider the surface of a neutron star. Here, a mass greater than that of the sun has collapsed into a sphere barely the size of a city. Gravity is so crushing that mountains can rise only a few millimeters before collapsing under their own weight. A single teaspoon of neutron star matter would weigh as much as a mountain on Earth. On the surface, atoms cannot exist. Electrons are forced into protons, creating neutrons packed together in a density beyond comprehension. If you stood there, your body would be flattened to a thin film in an instant, your molecules fused into the star itself. Light bends around the surface. Time slows and the magnetic fields are so intense, they can tear apart molecular bonds from across space. A neutron star is not simply a dead star, it is a cosmic anvil, where matter is hammered into new forms that should not exist. Move closer still, and the horror intensifies. Some neutron stars are magnetars, their fields so powerful that they distort the very vacuum of space. In these fields, the normal laws of electromagnetism begin to warp. Photons split, virtual particles appear, the fabric of reality churns. To approach a magnetar would be to enter a region where light itself behaves differently, where space is a storm of energy invisible, yet lethal. A living body could never enter such a domain, not because it would burn, but because the forces would tear it apart. At the atomic level, even matter itself is unsafe here. Accretion disks around black holes are no less hostile. Gas and dust falling inward spiral at nearly the speed of light, heated to millions of degrees. These regions shine brighter than galaxies, outpouring X-rays and gamma rays in relentless storms. Within the disk, matter is shredded into plasma, its particles colliding in violence beyond nuclear fire. To be inside such a disk would mean being stripped to ions, then further to quarks, before being swept into the event horizon. But the true nightmare lies not in destruction, but in the distortion. Space curves into impossible shapes. Time dilates so that moments for you become years for others. You could fall into the abyss and from your view, experience only seconds, while the universe outside moves on without you. To be caught here is not only to die, it is to lose your place in time itself. And then there are relativistic jets, the cosmic lances, launched from the poles of black holes. Plasma streams outward at near light speeds, guided by magnetic fields into beams that pierce intergalactic space. Within them, particles are accelerated to energies no human-built machine can rival. If Earth ever lay in the path of such a jet, our atmosphere would be blasted away in an instant. Radiation would sterilize the surface, oceans would evaporate, the planet itself stripped bare. But to be inside the jet is stranger still. You would move with particles accelerated so fast that relativistic effects dominate. Distances contract, time warps, reality bends around you. The jet is not just violent, it is alien, a place where energy overwhelms matter, and the rules we rely on cease to apply. Near the edge of a black hole, the event horizon marks the border between what we can know and what is forever lost. To an outside observer, anything falling in appears to freeze at the horizon, stretched and reddened until it fades away. But to the falling object, there is no pause, only the plunge into darkness. What lies beyond remains unknowable. Some theories suggest singularities, points of infinite density where physics breaks. Others imagine exotic states of matter, or even tunnels to new universes. The terrifying truth is that we cannot know. The horizon is not just a boundary in space, but in knowledge. It is the edge of reality,
a wall against which our understanding collapses. To approach it is to confront the ultimate abyss, one that consumes not just light, but certainty itself. There are other frontiers where physics turns cruel. Near light speed travel, for instance, is not a sanctuary but a gauntlet. As velocity increases, the universe itself becomes a weapon. Particles of dust become bullets, striking with the energy of bombs. Cosmic rays slam into you with devastating force. Time slows for you, but the radiation you encounter grows ever more deadly. To move quickly enough to cross the stars is to enter a corridor of lethal fire. The void itself, transformed into a minefield. The dream of starflight carries within it the nightmare of relativistic death. Even stranger are the environments inside dense star clusters. Imagine a sky so full of stars that night never comes, where nearby suns shine brighter than the moon does on Earth. At such proximity, gravitational encounters are inevitable. Stars steal planets from one another, fling worlds into the void, or hurl them into fiery deaths. To live in such a place would be to endure constant cosmic chaos, your sun forever under threat of being ripped away. The universe here is not stable, but a crowded battlefield, where gravity wages endless war. What unites these extremes is their hostility, not just to life but to existence, as we know it. On Earth, survival is a question of environment, of air, of temperature, of resources. In these domains, survival is not even possible in principle. Matter itself is torn, atoms dissolve, time fractures, energy overwhelms. They are places where the universe reveals its indifference, most clearly, where its laws continue but offer no comfort. And yet they are also the most fascinating. These extremes teach us the limits of physics, the boundaries of what is possible. They show us not only how fragile we are, but how creative the cosmos can be in its violence. To contemplate them is to be humbled by the scale of danger, awed by the depth of mystery. But still, there are horrors greater, not in isolated stars or black holes, but in the grand motions of the cosmos itself. Galaxies colliding, superclusters merging, dark matter shaping invisible battlegrounds. The next step takes us into these vast arenas, where terror is measured not in stars or planets, but in the fate of entire galaxies.
When we imagine galaxies, we picture serene spirals, elegant arms unfurling in starlight, but galaxies are not delicate. They are predators, hunters and prey. Gravity pulls them together, over billions of years, dragging their stars, planets, and black holes into collisions so vast they redefine the sky. To live in such a universe is to live in a place where beauty and destruction are inseparable, where entire galaxies are devoured as casually as an animal eats its prey. Our own Milky Way is not immune. Even now, it is on a collision course with the Andromeda Galaxy. In 4 billion years, the two spirals will meet, and the result will not be a gentle blending, but a drawn-out war, lasting eons. Stars will be thrown into new orbits, entire systems cast into intergalactic exile. Planetary skies will change, as suns are torn from their homes and flung into the void. The elegant spirals will warp, their arms shredded and twisted into long streams of stars stretching across space. By the end, the two galaxies will merge into one vast elliptical, a bloated giant without the graceful arms that once defined them. For any civilization alive to see it, the night sky will become a theater of awe and terror, with a galaxy filling the heavens, brighter and larger than the moon ever was. This fate is not rare, it is universal. Galaxies collide everywhere. The Hubble Space Telescope has captured snapshots of these encounters. Galaxies ripped apart into tidal tails, their cores colliding in brilliant outbursts of star formation. When galaxies merge, their gas clouds are compressed, triggering furious waves of birth and death. New stars ignite by the millions, shining briefly before exploding in supernovae. To be inside such a galaxy is to live amid a storm of creation and annihilation, where the night is filled, not with steady stars but with sudden flares of cosmic violence. It is breathtaking, and it is lethal. At the heart of many galaxies lie supermassive black holes, monsters millions or billions of times the mass of our sun. When galaxies collide, their black holes sink to the center of the merged galaxy, spiraling around each other in a gravitational dance. Eventually, they merge in a titanic collision, releasing gravitational waves that ripple across the universe. For a nearby world, the effects would be unimaginable. Space itself would flex and tremble, distances stretching and shrinking as the wavefront passed. To live through it would be to feel reality itself vibrating beneath you. Yet even this is not the true horror. The greater terror is what happens to anything caught between the merging black holes, stars shredded, planets torn apart, energy released in jets brighter than galaxies. The centers of merging galaxies are graveyards, littered with the ruins of entire systems consumed by their masters. Dark matter, too, plays its role in this violence. Though invisible, it outweighs normal matter by a factor of 5, forming the scaffolding on which galaxies grow. During collisions, dark matter halos pass through each other largely unhindered, dragging galaxies along, but their gravity sculpts the outcome, bending light into distorted arcs and dictating which stars survive and which are lost. To live in a universe dominated by dark matter is to live in one ruled by a substance we cannot see, cannot touch, cannot escape. Our lives, our history, our future, all are written, not in the visible stars, but in the invisible hand of this hidden mass. The terrifying truth is that the universe we see is only a shadow, a faint glow against a backdrop of something vast and unseen. Galactic cannibalism is another common fate. Large galaxies consume smaller ones, stripping their stars and leaving only faint trails behind. Our own Milky Way has done this many times, and even now, it devours the Sagittarius dwarf galaxy, its stars stretched into rivers across the sky. To watch this from within would be to see your galaxy slowly vanish, your stars stolen, your home dissolved into the greater body of a predator. No resistance is possible. The smaller galaxy always loses, its history erased, its identity consumed. In some regions, collisions are constant. In dense galaxy clusters, galaxies lie so close together that their interactions never end. The Coma cluster, for instance, is a battlefield of giants. Galaxies here are stripped of their gas, left barren, and unable to form new stars. The cluster becomes a graveyard, filled with red, aging suns, no longer able to create. To live in such a cluster would be to live under skies where youth has vanished, where every star you see is old, dim, and dying. The very air of the cluster, its hot plasma, ensures no new life will ever form. It is not a cradle, but a tomb. And then there are ring galaxies, formed when one galaxy passes directly through another. The intruder's gravity sends shockwaves rippling outward, compressing gas into a brilliant ring of star formation. They are among the most beautiful sights in the universe, vast wheels of light, shining across space. But beauty masks violence. Inside the ring, chaos reigns. Stars are hurled into unstable orbits, systems are disrupted, worlds are thrown into darkness. To see the ring from within would be to watch the sky explode into fire, a luminous circle of doom, spreading outward, while your own star trembles under invisible forces. Even more terrifying is the scale of time involved. These collisions unfold over billions of years, far longer than any human life or civilization. Yet for those who endure them, the sky would be in constant flux. Constellations would shift not slowly, as they do on Earth, but dramatically over generations. Stars would brighten, dim, vanish, reappear. To live through a galactic collision is to live in a world where the heavens themselves are never still, where the sky is always telling you that destruction is underway. Galaxies are not stable, eternal islands. They are temporary gatherings, subject to constant reshaping, doomed to merge, to be consumed, to fade. To realize this is to understand that even on the grandest scales, permanence does not exist. Our Milky Way is only a phase, a fleeting structure on the way to something else. Its beauty is not security. It is the glow of a system already in motion toward its end. But as terrifying as galactic collisions are, there are forces even more incomprehensible, forces that do not merely move stars, but determine the fate of the universe itself. Dark matter is only one shadow. Dark energy is another, more mysterious still, a presence that drives galaxies apart and accelerates the expansion of everything. To continue our descent, we must confront this final enigma, the invisible power that defines the largest scales of all. There is a force in the universe, more mysterious than black holes, more elusive than dark matter, and more terrifying in its implications. It is called dark energy, and though invisible, it shapes the fate of everything. We discovered it only recently, by measuring the light from distant supernovae. Those dying stars revealed something shocking. The expansion of the universe is not slowing down under gravity, as expected, but speeding up. Galaxies are not simply drifting apart, they are being driven away from each other, faster and faster, pushed by something we cannot see or touch. That force is dark energy. It is everywhere, woven into the fabric of space-time, a pressure that fills the cosmos. And though we cannot measure it directly, it accounts for nearly 70% of all that exists. To understand the horror of dark energy, imagine the universe as a vast sea of galaxies. Over time the sea is stretching, currents pulling everything farther apart. At first the pull is gentle, but it grows stronger, accelerating with each passing eon. Galaxies that were once neighbors drift beyond reach, their light red shifting, until it fades into darkness. The night sky grows emptier, stars still burn,
but their light can no longer cross the chasm of space. Civilizations living billions of years from now will see only their local galaxies, cut off from the rest of the cosmos. They will never know there was once a universe filled with galaxies, because dark energy will have hidden them forever, but the acceleration does not stop. If dark energy remains constant, the future is a slow isolation, an endless stretching, where every galaxy outside our local group eventually slips beyond the cosmic horizon. We will be left in solitude, surrounded only by the remnants of our own cluster, while the rest of the universe becomes unreachable, invisible. The cosmos will not shrink in violence, but expand in silence, leaving us imprisoned in an island of stars, amid infinite black. It is a future not of fire, but of loneliness. If dark energy grows stronger, the vision becomes more terrifying still. In that scenario, the expansion does not merely pull galaxies apart, it accelerates so violently that even gravity cannot resist. Stars will be torn from galaxies, planets will be stripped from their stars, eventually the very atoms that make up matter will be ripped apart, their nuclei shredded as space itself expands faster than the forces binding them. This is the Big Rip, a universe ending not in collapse or cold silence, but in an act of ultimate dismemberment. Space-time itself is pulled to pieces, leaving nothing behind. And yet we do not know if dark energy is constant, growing, or something else entirely. It might be an illusion, a sign that our understanding of gravity is incomplete. Perhaps Einstein's equations need rewriting, or perhaps there are hidden dimensions leaking energy into our world. The truth is, we do not know what dark energy is. It has no direct signature, no particle, no field we can point to. We know only its effect, acceleration. It is a shadow with no body, a whisper we hear only by what it does to galaxies. To build physics on something so uncertain is to admit that we stand on unsteady ground, our models incomplete, but the consequences of its presence are undeniable. Dark energy defines the largest scale of the cosmos. It tells us that the universe is not static, not eternal, not even stable in the way we once believed. It is dynamic, restless, driven by something we cannot explain. And in this restlessness lies its terror, for it is not content with galaxies drifting. It is not content with stars fading. It pushes forward, endlessly, remorselessly, dragging everything into a future that no civilization can resist. Think of what this means for intelligence, for meaning itself. If civilizations arise billions of years from now, they will look into their skies and see only darkness beyond their local galaxies. They will never know the truth of the cosmos. The evidence will be gone, erased by expansion. To them, the universe will appear small, finite, isolated. The cosmic web, the clusters, the great voids, all will have vanished. They will never suspect the grandeur that once was. Dark energy is not only a destroyer of galaxies, it is a destroyer of knowledge, ensuring that the full story of the universe can be known only by those who live now, in this brief cosmic moment, when the sky is still rich with galaxies. Some speculate that dark energy might fluctuate, that it could reverse, halting expansion and triggering collapse. If that happened, the universe could end in a big crunch, followed by another big bang. But if it does not, if dark energy continues, then the universe is fated for isolation, for fragmentation, for a future where every observer is trapped in their own island of stars, unable to communicate with, or even see the. It is a prison sentence written into the structure of space-time itself. The scariest part of all is that dark energy is not far away. It is not hidden in some exotic object, or distant cluster. It is here, around us, flowing through every cubic meter of space. Right now, between your eyes and the screen you are reading, dark energy exists. It is not strong enough to tear you apart, not yet, but it is there, pushing galaxies apart, shaping the destiny of everything. We live inside it, as fish live inside water, unable to escape. It is the medium of our existence, and it is leading us to an end we cannot resist. So we are faced with a truth, both humbling and horrifying. The most powerful force in the universe is one we do not understand. Dark energy controls the fate of galaxies, of stars, of atoms, of everything, and yet, it remains a mystery. It is invisible, untouchable, unknowable. We are at its mercy. But even this is not the final horror. Beyond dark energy lies another possibility, one stranger still, that the universe itself is not ultimate, that we are part of a multiverse, an endless sea of realities, most of them far stranger and deadlier than our own. To step into that idea is to confront infinities of terror, endless variations of destruction. That is where our path must lead.
What if our universe is not the only one? What if what we see, the galaxies, the clusters, the web of stars, is only a tiny bubble in a far larger sea of existence? This is the unsettling idea of the multiverse. And it is perhaps the most frightening concept of all, for it means our universe, with all its terrors, might not be special. It may be just one of countless others, each governed by laws that may be wildly different from our own. If that is true, then reality itself becomes unstable, fragile, and deeply alien. One vision of the multiverse comes from eternal inflation. The theory suggests that in the earliest moments, after the Big Bang, space expanded at an exponential rate. In some regions, this inflation slowed, allowing galaxies and stars to form, but in others, it never ended. Instead, inflation continues, endlessly creating new bubble universes that sprout like foam on the surface of an infinite ocean. We live in one such bubble, but beyond our horizon are countless others, unreachable, each with its own physics. Some may have no stars, no atoms, no light. Others may host strange forms of matter, or time itself unfolding in alien ways. To imagine this is to realize that our universe is not the whole of reality, it is only a drop in a storm, without end. But the multiverse is not safe. Bubbles can collide. If another universe brushed against ours, the collision would release energy on a scale we cannot comprehend. It would rewrite the laws of physics in the overlap, erasing everything we know. Entire galaxies, stars, and planets would be dissolved, replaced by new structures, built from alien rules. There would be no warning, no defense. The universe could simply sweep across us like a wave, leaving nothing behind. Some scientists believe faint circular patterns in the cosmic microwave background may be scars from such collisions, hints that universes have already crashed into ours. If true, then our universe bears wounds from battles fought on scales beyond imagination. There are darker versions still. Some universes may not be stable at all. They may collapse into themselves, after only moments, their laws of physics unable to sustain them. Others may be filled with forces, or constants that make life impossible. Universes where gravity is too strong and stars collapse instantly, or where it is too weak and galaxies never form. The multiverse then is not a place of endless possibility, but a graveyard, an infinity of failures. Our universe is habitable, not because it is typical but because it is rare, a fragile oasis in a desert of sterile realities. To know this is to feel not comfort, but terror. For if we are an accident of probability, then our place is precarious, temporary, and utterly replaceable. There are even theories that suggest our universe might be a simulation, one reality nested inside another. If so, the laws of physics are not ultimate truth, but rules written by some higher system. Everything we know, particles, galaxies, even consciousness, could be an emergent illusion. If the simulation ends, so do we. It may already have happened countless times in other simulated realities, each spun up, and then shut down. To live in such a world is to live under the constant possibility that our existence could be switched off without warning, without reason, by hands we will never see. The multiverse also brings with it the horror of infinite variation. If there are endless universes, then every possible history is realized somewhere. There are universes where Earth never formed, universes where humanity never evolved, universes where different laws produced beings beyond our comprehension. There may even be universes nearly identical to ours, where other versions of you are living different lives, some happier, some doomed. Infinity ensures that every possible outcome exists. And in such a framework, meaning becomes slippery. If everything happens somewhere, does anything matter here? The terror is not just physical, it is existential. The multiverse does not merely dwarf us in scale, it dissolves uniqueness itself. Worse still, if universes can collide, if new ones are born endlessly, then our universe may not last forever. It could be devoured by another, or superseded by a more stable one. We may already live inside a bubble destined to collapse, its vacuum unstable, its end rushing toward us, at the speed of light. In that scenario, we would never know until it happened. One moment, life would continue as normal. The next, the laws of physics would shift, and every atom would dissolve into something else. This is vacuum decay on a cosmic scale, not just within a universe, but between universes. And yet, the multiverse is not only terrifying because of what it implies about destruction. It is terrifying because it implies insignificance. We once thought Earth was the center of everything, then learned it was only one planet among billions. We once thought the Milky Way was the universe, then discovered countless galaxies. Now we must consider that our entire universe may be only one among infinite others. Each step has stripped away our centrality, our importance, our safety. The multiverse is the final strip. It tells us we are not even part of a grand story, but one of countless stories, most of them unread. If the multiverse is real, then the scariest places in the known universe are not in black holes, not in galaxies,
not even in the void. They are beyond our universe, in realities we cannot reach, or even perceive. They are places where nothing we know applies, where physics itself becomes alien, and if we are unlucky, one of those universes may already be moving toward us, ready to erase us in silence. But before we reach that ultimate uncertainty, there is one final frontier to consider. The strangest, most haunting place of all, not out there among other universes, but here, within ourselves, in the mystery of consciousness. For the universe is not just matter and energy, it is also aware of itself, through us. And the scariest place may not be in space, but in the mind, where reality and meaning themselves unravel. The scariest places in the known universe are not always vast or distant. Sometimes they are intimate, hidden not in galaxies or black holes, but in the very thing that makes us aware of them. Consciousness. For the universe is not just stars and voids, it is also the experience of stars and voids, filtered through fragile mind. And what terrifies us most is not always annihilation, but what annihilation means. We rarely think about it, but everything we know of reality, every galaxy, every particle, every law of physics, is mediated by consciousness. Without it, the universe would still exist, but there would be no one to perceive it. Our entire grasp of the cosmos is built not on direct access, but on the flickering signals processed inside our brain. This means that the most alien, the most dangerous environment may be the interior one, where perception itself can warp. Dreams remind us how fragile reality feels. Entire worlds conjured in seconds, only to dissolve upon waking. Hallucinations show us how easy it is for the brain to fabricate. If the cosmos is terrifying in its violence, the mind is terrifying in its unreliability. And then comes the greater horror, that consciousness itself may be temporary, an accident, a brief flare produced by matter and destined to vanish. The stars will burn for billions of years, galaxies will merge and collide, black holes will last for trillions. But our thoughts, the awareness you feel right now, may end in decades. The universe may continue without witness, without meaning. To contemplate this is to realize that consciousness is the most fragile thing in existence. Compared to neutron stars or supermassive black holes, it is nothing, yet it is also everything, because without it nothing is known. The fear of cosmic annihilation, the big rip, vacuum decay, the heat death of the universe, is terrifying not only because it destroys matter, but because it destroys awareness. There is no terror in nothingness itself. The terror lies in imagining the transition, the lights going out, the last thought extinguished, the silence after. Every cosmic horror becomes an echo of a deeper one, the end of being aware. But consciousness may not be what we think. Some physicists and philosophers suggest it is not an emergent accident, but a fundamental feature of reality, woven into the structure of existence itself. If so, then perhaps consciousness endures beyond matter, scattered across universes, preserved in ways we cannot yet imagine. This possibility is strange, unsettling, and perhaps more frightening than extinction. For if consciousness cannot end, then it may persist, through every cosmic horror, heat death, big rip, vacuum collapse, trapped, enduring, without body or world. Eternal awareness in eternal darkness. Survival not as blessing, but as curse. Even within our lifetimes, the fragility of consciousness shows itself. Memory fails, diseases dissolve the self, entire identities unravel while the body continues. Here we see, in miniature, the fate that may await the cosmos itself, structure breaking down, complexity unraveling, until only fragments remain. We dread the collapse of galaxies, and the death of stars, but the collapse of thought is closer, and far more immediate. If the universe is terrifying in the long term, the mind is terrifying in the short. And yet, here we are, fragile, finite, temporary, looking out into a cosmos of extreme. We peer into the abyss of black holes, into the silence of dark energy, into the chaos of colliding galaxies, and into the shadows of the multiverse. We ask what it all means, knowing there may be no answer. The scariest place may not be out there at all, but in the confrontation with that emptiness. When we realize that the universe owes us no explanation, and that meaning may be something we invent against the void. Still, there is something awe-inspiring in this confrontation. Consciousness, fragile though it is, can encompass galaxies. It can imagine the end of time. It can stretch itself to consider infinities of other universes. In doing so, it turns terror into knowledge, and knowledge into wonder. The scariest places in the universe are terrifying precisely because we can understand them. Awareness makes them unbearable, but also meaningful. Perhaps that is the paradox of existence. The universe is vast, violent, indifferent, and destined for ends we cannot escape. Consciousness is fragile, fleeting, prone to collapse. And yet, when they meet, when a mind contemplates the abyss, something extraordinary happens. Terror itself becomes part of the story of the cosmos, as real as stars and black holes. The scariest places exist, but so does the act of naming them. When we look into the night sky, we see beauty, But behind that beauty are horrors, collisions, implosions, isolation, erasure. Beyond that there may be other universes, stranger and more hostile. Beyond even that, there may be nothing, or awareness that persists, beyond all. The universe is not safe, it never was, and it never will be, but it is ours to witness, ours to name, ours to fear, and maybe in the end, that is what makes it bearable. To know that in all the violence and silence, in all the infinite black, there was once a moment, when the cosmos looked at itself, through human eyes, and felt fear. A brief moment, yes, but real. A flicker of awareness, against eternity. A fragile flame, burning in the scariest places of the known universe.